we're speaking about the voltage gated sodium channels. And their involvement in the action potential. The first thing we want to understand is that the voltage gated sodium channel is voltage sensitive. Which simply means that it's going to open at negative 55 millivolts and close at positive 30 millivolts. Okay. We also want to remind ourselves that there are two gates involved with this channel. There's an activation gate that is voltage dependent. And there's also an inactivation gate that is both voltage and time sensitive. Okay. So let's look at the three states of this gate. So that's the first state of our channel. The second state of our channel has to do with opening up of the activation gates. And opening up of the inactivation gates. And then this third state of our channel is where the activation gates are open, but the inactivation gates are closed. Okay. So let's describe this here a little bit. So in this state, the channel is closed, but capable of opening. This is when the membrane potential is negative 70 or at rest. And what we have is the activation gate closed, but the inactivation gate is open. And basically, the channel is capable of being open because the inactivation gate is open. So all we need to do is get to negative 55, we'll open up the activation gates, and because the inactivation gate is already open, we then can open up this channel, right? So we then depolarize this cell. Let's say we fire a few graded potentials, and we depolarize to threshold, which is our negative 55 value. Then that triggers the opening up of the activation gate. So in phase 2 here, the channel is open. And that is because the activation gate is open. And the inactivation gate is also open. Okay. Now, when the inactivation gate gets to negative 55, there's a 1 millisecond delay here. And that's what we mean by the inactivation gate being voltage and time dependent. So at this negative 55 threshold, we have a 1 millisecond delay to then close this inactivation gate after that 1 millisecond. Right? So here we have that 1 millisecond delay. Okay, so at negative 55, there's a 1 second trigger here to then close this gate after that time. And then in the third state of this channel, the channel is closed. But here it's incapable of being opened. And that's because the activation gate, although that is open, the inactivation gate is now closed, and so we cannot open this gate again until the membrane potential gets back down to rest. Okay. And this is basically repolarization which is triggered at positive 30 millivolts. Okay, so let's kind of go through this here and summarize here one more time. So we had our two gates on this channel. There's an activation gate and an inactivation gate. The activation gate is voltage dependent only. The inactivation gate is both voltage and time dependent. So at rest, we start with this channel closed, but there's a possibility to open it if we get to threshold, right? So the inactivation gate is open, but the activation gate is closed. If we have a few graded potentials and we get to threshold, we then trigger the opening up of the activation gates, and we trigger this 1 millisecond delay to close this inactivation gate after a millisecond. Okay? And so at negative 55, our channel is open because both gates are open. When we get to positive 30, this is where this whole thing stops, right? This is also where the inactivation gate has closed because of the signal that was sent over here. So when the inactivation gate closes, the channel is now closed, even though the activation gate is still open. The channel is closed here and incapable of being opened until our membrane potential repolarizes all the way back down to rest. That's when we'll have the activation gates closing once again and the inactivation gate opening once again. Okay.